All right, so the properties here. Non-isosceles trapezoids, specifically non-isosceles trapezoids. Non-isosceles means that these legs here that are not the parallel lines are not congruent, okay? Only one pair of opposite sides are parallel, okay? That is true for all trapezoids, non-isosceles and isosceles. Consecutive angles between parallel lines are supplementary, all right? Consecutive angles between the parallel lines are supplementary, all right? Isosceles trapezoids have these same properties, so they include these two properties. You add some other things, non-parallel sides. These legs are congruent. Diagonals are congruent. Base angles are congruent. So that's these and these, both sets of base angles. Opposite angles are supplementary. Opposite angles are supplementary. All right. Okay, any questions on that? All right, let's look at some of these examples. All right, so they've given us two of the measures in this trapezoid. They want the other two. The measure of angle K. The measure of angle K. So we have 87 degrees, and they want measure of angle K and measure of angle M. Now, if you'll look above this, it says consecutive angles between the parallel lines are supplementary. So by that, they mean between these parallel lines, these are going to be supplementary and these are going to be supplementary. Okay, so just the consecutive angles that are between the parallel lines are supplementary. All right, so that means M is supplementary to J and K is supplementary to L. So if they want K and we know L, all we have to do is subtract from 180. So we're going to say 180 minus the 51. And that's going to give us 129 degrees for K. So then if we want M, that is going to be supplementary to J. So we would say 180 minus the 87 degrees, and we would get 93 degrees for this. 93 degrees for that. All right? Now you have to pay attention to trapezoids because orientation is important. You're used to the orientation of a trapezoid being the parallel lines on top and bottom from your perspective. That's not necessarily how it's going to look. So if you look at number 3 here, these are the parallel lines. All right. So the consecutive angles between the parallel lines then would be these two angles. Okay. So we're talking about between the parallel lines. So pay attention to how it is on your page. It's not necessarily what it's going to feel like when you're doing this. It's not always going to be top and bottom like the one above it was. Okay. So for this one, that means these two would be supplementary. So if they want us to solve for x here, we are going to simply set this up. 54 plus 8x plus 6. Supplementary means they add up to 180. All right, because those are between the parallel lines. So we're going to combine our like terms here. We will subtract that 60 over. And then we will divide by the 8. All right, so if they want us to solve for x here, we would just look at what we have and solve accordingly. If we know they're supplementary, we're going to set them equal to each other and solve, or set them equal to 180 and solve. Let's go ahead and try the 2, 4, 6, and 8. Your base, your legs are congruent. Your base angles are congruent for an isosceles trapezoid. So if they tell you it's isosceles, your base angles are congruent. That's your top and your bottom. Remember, you have two bases. And your legs are congruent. for number 2. C was supplementary to B. So 180 minus 31, you would have gotten 149. D was supplementary to A. So 180 minus 62 is 118. This wanted you to find the measure of angle R. So first you had to find X. Q and R are supplementary. So you should have had Q plus R equals 180. 12X and 7X are 19X. 3 and negative 13 are negative 10 equals 180. When you solve, you get X equals 10. You're not finished though, because it asks for the actual angle measure. So you need to take 10 and plug it into R. 7 times 10 minus 13, that angle measure was 57 degrees. For this one, they told us this was isosceles, so they just wanted to test your knowledge of what's congruent. Angle T was congruent to angle U, angle V was congruent to angle W. And then again, testing your knowledge here. X was congruent to W, base angles are congruent. Y and Z would have been both supplementary to X and W. So subtract from 180, 133 for both of those. All right. The mid-segment of a trapezoid connects the midpoints of the legs, okay? So you have parallel lines. Those are your bases, A, B, and DC in this particular case. And then you have the midpoint of the legs. So the midpoint of E and the midpoint of F. At F, and midpoint E is A to D. That's the midpoint. F is the midpoint of B to C. And this segment that joins the midpoints is called your mid-segment. Mid-segment. If EF is the mid-segment of this trapezoid ABCD, there are some characteristics that happen here. First, all 3 of these lines are parallel. We already know by definition for a trapezoid that AB is parallel to DC. But if you put the mid-segment in there and those are the midpoints, then EF is also parallel to those 2 lines. So EF is parallel to AB and to DC. Okay? The other thing that happens is that the length of EF is going to be half of the sum of your bases, okay? So to find EF, you can add the length of AB and the length of DC, add those 2, and then divide by 2. So it's basically the average of your bases, okay? So your mid-segment length is the average of your 2 bases, all right? And so several problems or questions can come up from these. So let's look at the first example that they gave us here. So here they gave us the mid-segment of 22. They gave us one base of 38. They want us to find the other base. So here we're just going to use basic algebra to solve. What I'm looking for is the AB. So to solve this, the first thing I have to do is multiply by the 2. Multiply that on both sides. All right, so when I do that, I can cancel that. I'm going to get 44 equals 38 plus AB. Then to solve for AB, I'm just going to subtract the 38. So the length of AB is going to be 6. So that's the other thing they can do. They can give you the mid-segment and ask you for one of the bases. So you need to make sure you know what you're solving for. All right? You always want to know what you're solving for. And then the last example here on this particular one is throwing in some variables. In this case, they want us to find the length of YZ. So in order to find the length of YZ, we have to find X first. So we're going to set it up exactly the same. All right? We're going to say, well, the mid-segment, that's YZ, which is 5X minus 19, should equal the one base, 38, plus the other base, X plus 14, all over 2. Okay? A couple things we have to do here. We need to get rid of that 2, so we're going to multiply everything by 2. When we do that, this left-hand side is grouped, okay? So make sure you pay attention to the fact that that is grouped if there is a plus or minus in there. It will cancel on the right, and we have the grouping on the left. So we do need to distribute here 2 times 5x and 2 times 19. And on the right-hand side, we do want to simplify it. So if we have like terms, we want to put those together. So over here, we have our 38 plus x plus 14. So we want to add our 38 and our 14. And now we can just solve like we would any other time. Subtract your x over. This will give us 9x on the left-hand side. Add your 38 to both sides. That's going to give us 9x equals 90. And then, of course, I want to divide both sides by 9. Now, again, always know what you're solving for. X is going to equal 10. However, they ask us to find x or find yz. YZ is my mid-segment. So I need to take that 10 and I need to plug it into the equation for my mid-segment. So I need to say 5 times x, or 10 minus 19. So 5 times 10 is 50 minus 19 is going to be 31. So the length of YZ is going to be 31. All right? So go ahead and solve 2, 4, and 6 on this page. 2, 4, and 6 on this page. So for the first one, they gave you A, B, and D, C. Again, you're using the picture from the example at the top. So EF is your mid-segment. So you should have added the 7 and the 31 and divided by 2 to get 19. On the second one, just like our second example that we did, they gave you the mid-segment. They wanted one of the bases. So 47 equals 41 plus CD over 2. Multiply both sides by 2. Subtract your 41. You should have gotten 53 as your other base. And then the last one, the two bases, 2x plus 11 plus 6x minus 1 over 2 should equal your mid-segment of 25. Multiply both sides by 2. Combine your like terms, 2x and 6x, and 11 and negative 1. Subtract your 10, divide by 8, x is 5. You had to go one more step because they wanted KL or KJ rather. So 6 times 5 minus 1, you should have gotten 29. So let's look at the properties of the kite specific. We talked a little bit about this when we did our flow chart. We just listed them. Now we're going to actually do them with some algebra. A kite is a quadrilateral with the following properties. Exactly 2 pairs of consecutive congruent sides. So parallelograms have opposite congruent sides. Trapezoids only have potentially one set of congruent sides if it's an isosceles trapezoid. Kites have 2 pairs of congruent sides, but they are consecutive. All right, so that means that the 2 sides that are beside each other are going to be congruent. So these 2 sides are congruent, and these 2 sides are congruent. Okay, so that means AB is congruent to AD, BC is congruent to DC. 1 pair of opposite angles are congruent. All right, 1 pair of opposite angles are congruent. Here, angle B is congruent to angle D. So ABC is congruent to ADC. ABC is congruent to ADC. It is the angle that is in between the 2 sides that are not congruent. All right. So AB is not congruent to BC. It created this angle right here. AD is not congruent to DC, which created this angle right here. These 2 angles are congruent in a kite. Diagonals are perpendicular, okay? So the diagonal AC is perpendicular to BD, which means they meet at a right angle, all right? So those are your properties of kites. Those are your properties of your kites. So let's apply them here. All right, so for the properties here, we have a quadrilateral for number 1. We know that B is congruent to D, okay? So we know that B is congruent to D. but they haven't given us any other information. So we do not know, like in a kite, you can't say that they're supplementary, like consecutive angles aren't supplementary. But we do know it's a quadrilateral. So we do know something about the angle measure in a quadrilateral. We should know that a quadrilateral has a sum of 360, right? And how do we know that? Well, n minus 2 times 180, we've done this since the beginning of this chapter, okay? So I do know that all 4 of these should add up to 360, okay? So if I take 360 and I subtract the other 2 angles, all right, then I should get what B and D are together, all right? What B and D are together. So when I take 360 and I subtract 85 and 43, I should get 232, all right? So this is 232. Well, how does that help me? Well, B and D are congruent, so they're the same angle. So I should be able to divide this in half and get what they both are, because they're the same. So if I divide that in half, I should get 116 degrees, which is correct. Those are both 116 degrees, okay? So given those 2 angles, I can solve for the congruent ones by just subtracting from 360, all right? Like in a triangle, for isosceles triangles, I would subtract the vertex angle from 180 and divide by 2, all right? But in a quadrilateral, the kite adds up to 360. All right, let's look at the next one and see how this helps us. The next one is 37 degrees. 37 degrees. All right, so for this particular one, they asked me a few angles. So we're going to start with the first one that they ask us about. The angle that they're asking us about here is angle PTQ. PTQ. Well, one of my properties of a kite is that my diagonals are perpendicular. So I should automatically know what any angle of my 2 diagonals is. What is any angle of any 2 of my diagonals if they are perpendicular? What should they form if they are perpendicular? They should form right angles. What is the measure of a right angle? 90 degrees. So I know that PTQ is 90 degrees. Okay? I know that PTQ is 90 degrees. The next one they want is PQT. Well, if I know 37 and I know this one is 90 degrees, then I should be able to figure out PQT, which is this one right here. It's the third angle in a triangle. How would I solve for him? It's the third angle in a triangle, and I have 2 of them. What do triangles add up to? Yeah, subtract from what? 180. So if I say 180 minus 90 minus 37, I should get 53 degrees. 53 degrees, all right? Now let's look at the next one. They want me QRT. And this is not a property we've actually talked about, but we can get it from other information, all right? So first of all, I know that PQ is congruent to QR by definition for a kite, okay? I know that QT is congruent to itself, okay? By the reflexive property, anything's congruent to itself. I also know I have a right angle here. And I have some proof called hypotenuse leg that tells me those 2 triangles are congruent, right? If I have a right triangle and I have the hypotenuse congruent and a leg congruent, then the entire triangle is congruent, all right? Hopefully you remember that. They want this other angle. Well, that should be congruent to that angle if those 2 triangles are congruent, just by the property of what I have created. So what you've actually created with a kite is you've created congruent triangles here. You've created congruent triangles, which means those pieces are congruent as well. All right, those pieces are congruent as well. So if those pieces are congruent, then that means QRT should also be 37 degrees. All right, I know that QPS is congruent to QRS. So the pieces of those should also be congruent. The pieces should also be congruent, all right? And so we have a lot of properties thrown at us when we start getting these, because you basically create some congruent triangles with kites. Question. All right, so this is talking about the angles here. All of these are talking about the angles. All right. So we'll start with the first one that they ask us about. They ask us about angle 1. Angle 1. I know that my diagonals are perpendicular, so I know that these are right angles. Angle 1 is the third angle in a triangle. I have 65, 90, and 1. So I should be able to subtract 180 minus 65 minus 90, and I should be able to get that angle 1 is 25 degrees. All right, so I have angle 1 at 25 degrees just by my property of triangles. All right. We're going to jump around here a little bit. So we are going to look at angle 3. That's an easy one. Angle 3 is one of the angles created by my diagonals. So every angle created by the diagonal is always what? 90 degrees. 90 degrees, all right? If you look at what starts happening with these, you actually start having isosceles triangles that are created. So let's talk about the angle 2 here, all right? If I look at these triangles, I have this diagonal, right? And I have this side and this side. Does everybody see that triangle I've just highlighted, all right? In a kite, I know that this side is congruent to that side, yes? What type of triangle do I have if I have two congruent sides? I have an isosceles triangle, right? And so in this isosceles triangle, if it goes down to a perpendicular bisector, that bisector, and this is back from our memories of what happens to an isosceles triangle, that bisects the angle, okay? It bisects the angle. So that means angle 1 should be congruent to angle 2. So once I solved for angle 1, I actually solved for angle 2 as well. All right? I solved for angle 2 as well. Which means that if I have 52 right here, that is also an isosceles triangle because these two sides are congruent. So that means I also know angle 7. Angle 7 must also be 52 degrees. And then for 5 and 6, if it's an isosceles triangle, 5 and 6 are congruent. I just have to solve for one of them. And I can do that by my 180. So I have 90 degrees here. I have 52 degrees here. I subtract from 180 to get that one. And I'm going to get 38 for 5 and for 6. Number 4 is an isosceles triangle here. So 4 should be congruent across to the 65. So kite creates isosceles triangles. So it creates a lot of congruent angles. All right, think of it as two isosceles triangles put together. So you have these two isosceles triangles that are put together. So you have side lengths that are the same. You also have base angles of those isosceles triangles that are the same. So you start to create a lot of congruent angles in a kite is what happens. Just like your rhombus and your square, your diagonals are perpendicular for a kite, which means that you have these right triangles that are created. Anytime you have right triangles, you need to be aware you may have to use Pythagorean theorem when they start asking for lengths. It'll never apply to angles, right? It only applies to lengths. And so let's look at this one. They have WX is 14. WR is 8. They want R to Z, which is down here, which seems like it doesn't help us, all right? However, these are congruent. WX is congruent to WZ. And so I have this right triangle here. I know the hypotenuse is 14, and I know one of the legs is 8, and they're really asking for the other leg. So here I'm going to have to use Pythagorean theorem. The first leg, which is 8, second leg, which I don't know, squared. should equal my hypotenuse squared. And so anytime you have right triangles, you need to be looking for the fact that you could have a Pythagorean theorem situation. So you are going to have to take the square root. It may not be a perfect root, which in this case it is not. Just round to one decimal place or whatever your instructions tell you to do. All right, for these, I would have started with 1. If I have 46, I know 1 is also 46. 2 and 3, this is an isosceles triangle, so 180. And actually for this, you could have just said 90, 46 and subtract. You would have gotten 44, and 2 and 3 should be the same. It has been bisected. 4 is one of your diagonals. That's going to be 90. 5, you could have subtracted 73 and 73 are congruent to get that, and then subtract that from 180 to get 7, which also gives you 6. And then for the last one, you had to use the Pythagorean theorem here. If this is 38, those are each 19, and you can use Pythagorean theorem to solve for C, D. All right, your homework.